In Lesson 9.1, you will identify arithmetic sequences as well as write an expression to find the nth term in an arithmetic sequence. Take a look at the following pattern. To make one triangle out of toothpicks, it takes 3 toothpicks. To make 2 triangles like this, it takes 5. And to make 3 triangles, it takes 7 toothpicks. Continue the pattern for 4, 5, and 6 triangles. How many toothpicks are needed for each case? Well, if I wanted to make 4 triangles, I would have to add another one on like this, which would add 2 more toothpicks. So that's going to make it 9 toothpicks. And then for 5 triangles, I would have to add yet another triangle on, which would take 2 more toothpicks, which is going to be 11. And then for 6 triangles, I would add 2 more toothpicks to make it 13. This sequence, 3, 5, 7, 9, 11, 13, is called an arithmetic sequence. It's a sequence in which the difference between any 2 consecutive terms is the same, and that is known as the common difference. To go from 3 to 5, we added 2 toothpicks. To go from 5 to 7, we added 2. And from 7 to 9, we added 2, and so on. To get to the next term in the sequence, we always added 2. So the common difference was 2, or that's the difference between any 2 terms. In the first example, we are going to try to state whether or not a sequence is arithmetic, and if it is, give the common difference and write the next 3 terms. So as I look at this sequence, 17, 12, 7, 2, negative 3, to go from 17 to 12, the difference between those 2 terms is negative 12 minus 17 is negative 5. It went down 5 to go from 17 to 12. From 12 to 7, it went down 5 again. And from 7 to 2, it went down 5. And from 2 to negative 3, it went down 5. Again, you can find out that number by taking a term and subtracting the term in front of it. So this one is an arithmetic sequence, and the common difference, since it was going down by 5, is negative 5. And then the next 3 terms, after the negative 3, if I take 5 more away, we are at negative 8. And then take 5 more away, that's negative 13. And then 5 more away is negative 18. Why don't you pause the video and try the next 2 on your own. From 2 to 6, it increased by 4. And from 6 to 10, it increased by 4. From 10 to 14, it increases by 4. And from 14 to 18, it increases by 4. Again, one way to check that is to subtract one term minus the term in front of it, 18 minus 14 or 14 minus 10, and so on. So this one is, yes, it's arithmetic. The common difference, or what it's changing by, is 4. And since it is increasing by 4, it's positive 4. And then the next 3 terms, if I increase 18 by 4, I get 22. Then increase it by 4 more, and I get 26. And then by 4 more, and we get 30. In our next sequence, negative 4 to negative 8, that went down 4 units, or minus 4. Again, you can find this by doing negative 8 minus negative 4. Now to go from negative 8 to negative 16, that went down 8. And from negative 16 to negative 32, it went down by 16. Now there is a pattern here, but it is not an arithmetic sequence. It's not an arithmetic sequence because it doesn't have a common difference. Now I want you just to consider the two examples we just got done doing that were arithmetic sequences. If I put them into a table like this, taking this first sequence, if the first term was 17, the second one 12, the third one 7, fourth one 2, fifth one -3, one thing that I know is that the common difference was -5. It decreased by 5 every time. So if I take the term number and multiply it by -5, that will help me get to an expression that will help you find any term you want. So for example, if I took 1 and multiplied it by -5, I would get -5, and I'm supposed to end up with 17. If I take 2 and multiply by -5, I get -10, but I'm supposed to end up with 12. What else do we need to do so we end up with these numbers over here? If I take the 1 and multiply it by -5, I get -5. -5, what do I need to add to it to get to 17? That's right, you need to add 22. Let's see if that works for the next one. 2 times -5 is -10. -10 plus 22 is 12. 3 times -5 is -15. And -15 plus 22, that is 7. So it seems to be following the pattern. Now, I want you to look back here and consider if I went backwards to the term before the first term. Instead of taking away 5, if I wanted to go backwards, I would add 5 on. If I add 5 on to 17, I end up with 22. I just got done telling you that if I take the term number, or n, and multiply it by -5, its common difference, and then add 22 more to it, I get this number over here. So if you'll notice, this ends up right here, and this ends up right here. Let's look at the next example. To go from 2 to 6, we added 4. Added 4, and so on. So 4 is the common difference, or what we multiply by. So 4 times n, or the term number. If I did 4 times 1, I'd get 4, but I'm supposed to get 2. And if I do 4 times 2, I get 8, but I'm supposed to get 6. If I do 4 times 3, I get 12, and I'm supposed to get 10. I keep getting 2 more than I'm supposed to, so I think what I need to do is subtract 2. Now, if I do what I just talked about over here and went backwards to the term before the first term, or the 0 one, instead of adding 4, if I'm going backwards, I would subtract 4. And 2 take away 4 is -2. Notice this number right here is what you multiply by, and this number right here is what else is being done to it. In this case, it's -2. Over here, it was plus 22. This one's plus 22 because it's positive. This one is -2 because it's negative. That leads me to a rule that you'll want to make sure to get down in your notes. The nth term of an arithmetic sequence is equal to the common difference times n, or the term number, plus what else needs to be done to it. And you can find that by going to the term before the first term. Let's try these next two here. Write and solve an expression that can be used to find the nth term. To find the nth term, we need to know the common difference and the term before the first term. So if I go from 5 to 11, and then 11 to 17, and 17 to 23, I'm increasing by 6 every time. So the number I'm going to multiply n by is going to be 6. So 6n. And then I have to figure out what else I need to do. Well, 6 times 1 is 6, but I'm supposed to get 5. And 6 times 2 is 12, but I'm supposed to get 11. That leads me to believe I should be subtracting 1, and I can tell for sure by going back to this term before the first term. If I went backwards, instead of adding 6, I would take away 6, and I would end up at -1. And since it's -1, it's going to be -1. Now this right here is the expression to find the nth term. And now to find when we're talking about n equaling 10, or the 10th term, you're going to take this and plug it in right here. 6 times 10 minus 1. 6 times 10 is 60, and 60 minus 1 is 59. So the 10th term is 59. For our next one, to go from 15 to 5, that is decreasing by 10. 5 to -5 is decreasing by 10, and so on. So -10 is what I'm going to multiply by. So -10 times n. Now we have to figure out what else needs to be done. -10 times the first term is -10, but I'm supposed to be at 15. And then -10 times 2 is -20, and I'm supposed to be at 5. It looks like we are going to be adding 25 every time. And I can verify that by going back to the term before this. The one before this would be +25, because instead of subtracting 10, you would add 10 to go backwards. So our expression is -10 goes in front of n, and the 25 goes here at the end. So this right here is the expression to find any term number you want. And then now to find the 25th term, we're going to do -10 times 25 plus 25. -10 times 25, that's going to be -250. -250 plus 25 is going to be -225. You may want to pause the video and try the last two on your own. First, you want to look for the common difference. To go from -2 to -4, that decreased by 2. And it decreased by 2 again and again. So that's our common difference. That's the number that goes in front of n. And now to find the other piece of it, we have to see what else needs to be done to it. So we're going to go back to this term right here. Instead of subtracting 2, we're going to add 2. -2 plus 2 is 0. So this one is +0, but we don't really need to write +0. We can just leave it as -2n. So that is your expression. Now to find the 100th term, -2 times n, and n is 100. That's -200. Now our last example, to go from 5 to 3, that decreased by 2, decreased by 2 again. So our common difference is -2. So that's what we're going to multiply the term number by. And then we need to see what else needs to be done to it, this piece right here. So we're going to go backwards Instead of subtracting 2, we're going to add 2, and we would have a positive 7 here, so we would have plus 7 is the other piece. And we can check that because our first term, 5 times negative 2 is negative 10, or sorry, the first term is negative 2 times 1. Remember, n is the term number. Negative 2 times 1 is negative 2, and negative 2 plus 7 is 5. If you wanted to check it on this one, our second term, negative 2 times 2 is negative 4, and negative 4 plus 7 is 3. So that is the expression you can use. Now to find the 20th term, you're going to plug that in for n. Negative 2 times 20 plus 7. Negative 2 times 20 is negative 40. Negative 40 plus 7 is negative 33.